Okay, good day to all of you. So before we start our next chapter, let's have a recap of what have you learned in chapter 1. Okay, we have learned in chapter 1 the history of Arduino and then the parts of the Arduino boards, and then also we've also studied there the different types of um, Arduino boards. Why? Because it's an open source platform, so there are many variations, and then many boards that have derived from Arduino. So, but before we go to the programming part, so let's first learn about basic electronics because we're going to deal with different electronic components that will be used in the setup of an Arduino project. So let's start with chapter 2 with basic electronics. So what you will learn in this chapter, so what the four building blocks of an electronic circuit are, what a multimeter is, what some of the more popular basic electronic components are, what the properties of electricity are, how to use Ohm's law, and how to calculate power. So first, you're going to be introduced with the electronic building block. So what is this electronic building block? Okay, electronic building block is composed of input, control circuit, and output. And this is powered, of course, by the power supply. So in the succeeding slides, we're going to discuss what these parts are and what this do, of course, in electronic circuit block. So let's start with power supply. So the power supply is the source of electricity for the project. Any electronic device, any gadgets, any high-end computer without power supply, it will not be usable. So actually, power supply is very important because it runs. This is the source of power for your project. Next is we have the input. So the input block will contain electronic components that give the control circuit information. So the input block provides data that is to be processed by the control circuit. So these components give the control circuit the ability to sense the outside world. We have these types of examples for input. So we have buttons or switches. Buttons and switches can be used to turn the flow of electricity on or off. When they are in off state, the electricity will not flow through the circuit. However, when they are in the on state, electricity does flow through the circuit. So an actual example, of course, of the buttons or switches is the switches that can be found in your rooms for lighting the room. So that's already an actual example of a switch. And then temperature sensors. So temperature sensors adjust the amount of resistance in a circuit based on the temperature, causing the voltage to vary by the temperature. By reading the amount of voltage coming in, the control circuit can calculate the current temperature. So an example of a temperature sensor is, example, you have an air conditioning unit. You have a set temperature that if, for example, if the room becomes hot, for example, if it reaches 30 degrees, the air conditioning unit will run, and then again, it will have a set temperature. For example, if the room will reach the temperature 20 degrees Celsius, then it will stop. Meaning it's already not it's already convenient. It's not already hot inside the room. So that's the work of the temperature sensor. They're the ones who sense the actual temperature, for example, in the room. And then next is we have the range finders. There are many types of range sensors. However, the basic idea is the voltage that is outputted by the sensor varies depending on how close an object is to it. Like the temperature sensor, the control circuit can then calculate the distance based on the voltage coming in. So range finders are actually used in collision detection. For example, for cars, there are actually new cars available in the market that, for example, they have this safety that if there is something, for example, if there's another car, they can sense it so that collision detection, for the collision detection for it to work. And then another one is the proximity sensor. This is a sensor that is triggered when something gets within a certain distance of the sensor. A proximity sensor is usually either on or full voltage or off or no voltage. Actually, rangefinders and proximity sensors have the same application in real-world situation. I'll just give an example for a proximity sensor. For example, if you're in the mall, and then, for example, you're going to a stall, and then when you're entering that stall, automatically the door opens for you. Not because there's a person, but then there is a sensor that senses that people are approaching at the door, so it will automatically open. Okay, next is we have the output. So the output block will contain electronic components that do something. It is to be actuated, to be activated. So these components give the circuit the ability to interact with the outside world or to do something. So these are the examples of electronic components for output. So we have motors. So motors allow the circuit to turn something like a fan or wheels. This type of component turns electrical power into power that does work. And then we also have LEDs. So an LED or LED can be used as indicators to give visual feedback to the user. So actually, LED is used for status indicators. This type of component will turn the electrical power into light. And then we have the speaker. A speaker can be used to give audio feedback to the user. So this type of component will turn electrical power into sound. Speakers are very useful. For example, you have a burglar alarm system. There's a trespasser in the vicinity of your home, and then if that trespasser tries to barge in your house, and then if you have the burglar alarm system, the alarm will go off. So that alarm, actually, it is associated with the speaker as an output. And then next, we have the control circuit. The control circuit block is the electronic component that receives information from the input components, processes that information, and controls the output connections. Actually, the electronic building block is similar with combinational logic design block and also the computer system, the model. Because computer system is composed of input, the central processing unit, the output, and then they have memory. That's the only difference. But then the components are still there. There is an input, there is a processing unit, and there's also an output. And of course, since computer is a device, it is also powered by a power supply. Okay, next, after this electronic circuit block, we're going to discuss a very handy tool for analyzing circuits, and it is called a multimeter. Sometimes it is called multitester. So a multimeter, also known as a volt-ohm milliammeter, is an electronic measuring instrument that is typically used to measure voltage, current, and resistance. There are analog multimeters that operate by moving a pointer to display the measurement, but today, most multimeters are digital with an LCD that is used to display exactly what the measurement is. So how much is the multimeter? So a multimeter can cost as low as $10, so that is equivalent in the Philippines, approximately 500 pesos, and up to $400. Okay, $400 is approximately, oh my, 20,000 for a multimeter. For a really nice Fluke 87V, a brand of multimeter. So this is an example of a multimeter. So these are all digital. These are not analog. So we have two different types of multimeter, brands to be exact. So the digital multimeter has three main parts, which are the display, selection knob, and the probe ports. So let's go back with the image. So the multimeter has parts, and it is composed of the display, the selection knob, and the probe ports. So display, selection knob, and the probe ports. Okay, let's continue. So the display will show what the measurement is. Some of the higher-end multimeters have a backlit display, just like a smartphone, to make it easier to read in low light. And then the selection knob is used to select what we wish to measure. Most multimeters will read resistance in ohms, voltage in volts, and current in amps or amperes. So for the selection knob, there is a label. So this one is for the voltage, and this is for amperes, and this is for resistance. Okay, so volts, we have the direct and alternating, then for the amperes, and then for resistance. So it clearly has labels, so you will not be confused. And then probes are plugged into the probe ports, which are usually located on the front of the meter. So the black probe should be plugged into the port labeled COM or common or the ground, and the red probe will be plugged into one of the other ports depending on what is being measured. For example, if you're going to measure voltage or resistance, depending on the labels of for the red probe. Actually, there is no difference between the red and black probes. However, it is a good practice to always connect black probes and wires to common or ground and the red probes and wires to power, since this is the standard. So you have to follow the standards. It is more convenient. And of course, it is the standard. Okay, we have an example of an image. This one is in the volts, reading the voltage of this battery. Actually, this battery is a 9-volt battery. So because it's measuring volts, so its probe is connected to the with the labeled voltage. So we have 9.15, which is correct. It's a 9-volt battery. Okay. Next is we have a 330 kilo ohm resistor. We want to get the value of this resistor. Of course, since the first image is you have to get the voltage, or you want to know the voltage. So next is we want to know what is the resistance. So we'll select the knob and then select the 2 meg, and then also the probe. In the first image, it is connected here in the voltage part, but then since you're measuring resistance, you have to transfer because this is the label for resistance. And then as you can read, because this is a 330 kilo ohm, so it's 332. Actually, resistors have tolerance level. So we have this value. And then also, why does it is not exact as 330? Depending upon, because of course, the wires also have the resistance and depending on the manufacturer of the resistor. Okay, next image. Actually, this is the same resistor that is measured in the previous image. But why does the multimeter displays a value of 1 and then there's no change in configuration in the probe ports? It is because you put the selection knob in 200 kilo ohm. With 200 kilo ohm, since you are measuring a 330 kilo ohm, a value higher than the limit, so it will just display 1. So if you want again to correctly display the correct value of resistor, you have to return it to 2 meg so that it could read, because with 200K, the 300 kilo ohm, it's above its limits. So it will just output in the display, which is 1. Okay, next is we have electronic components. So we're going to discuss different electronic components. So we have resistor, potentiometer, switches, transistor, LED, capacitor, and integrated circuit. So let's go first with resistor. So a resistor is an electronic component that has a specific amount of electrical resistance that never changes. So the resistor limits the flow of electrons in the circuit. So that's why it is called a resistor, resistance in the flow of electrons. So these are examples of resistors. Okay, next is we have the potentiometer. The potentiometer, also known as a pot, is a variable resistor. So the potentiometer allows for the creation of a circuit where the user can change the resistance. So potentiometer comes in various shapes, sizes, and values, but they all have three connectors. The resistance between the two outer connectors is fixed and is the maximum resistance of the potentiometer. So the resistance between the center connector and either outer connection varies as the user turns the knob. So the potentiometer has lots of usages. So what are the practical applications of potentiometers? They could include audio control, motion control for servo motors, and control brightness of a light. So for example, if you want to, for example, in your radio, you want to turn the volume on louder. So if you turn the knob, actually that is already the potentiometer that you are using for controlling the loudness of your music in the radio. So this is an example of a potentiometer. This one in the center, it's the one that you are um, turning to the right or turning clockwise or counterclockwise. Otherwise, to control the volume or control the brightness of the light. So this is the one that is you are moving or turning. Okay, next is we have switches. So we have three types of switches that is shown here. So the push button switches are switches that are activated by pressing a button. These switches are usually used to start or stop some action. And then the micro switch is a switch that is activated by a light force being applied to a lever or button on the switch. These switches are widely used in many household and industrial applications. So examples of this are a micro switch for the end stops for a 3D printer, detecting if the door of a microwave is closed, and collision detection for robots. And then another one is we have the toggle switch. And this is activated and deactivated by moving the lever to the on or off position. So the toggle switch is mainly used to turn items on and off like a light switch. So we have the following images of the three switches that is discussed here. So this is a typical push button. This push button is actually used in the Arduino in the later parts. And then this is an example of a micro switch. And this is an example of a toggle switch. Okay, next is we have transistor. So transistors are tiny switches that can be triggered by an electric signal. Transistors are the building blocks for the digital world because transistors, this is the main component of the microprocessor, composed of millions and billions of transistors inside. A transistor has three connectors, which are known as the collector, base, and emitter. For NPN transistors, collector is the leftmost pin followed by the base and emitter. For PNP transistors, the leftmost pin is the emitter followed by the base and collector. The collector should be connected to an input power source. And then the emitter should be connected to a common ground in the circuit. The base, when a certain amount of voltage is applied, triggers the flow of electricity through the transistor. The base is what acts as a switch to turn the flow of electricity on or off. So that's why transistor has three pins. We have for the collector and base and the emitter. Okay, this is a transistor. But then again, as I've said earlier, that transistor are components of the microprocessor. It's a different form of transistor. This will not fit in the microprocessor because it is too big. Of course, these are very microscopic transistors that you cannot see in a naked eye. Okay, next is we have an LED or LED. So the light emitting diode, or LED for short, is a two-LED semiconducting device that emits light when a certain amount of current is passed through. When using a LED, we need to be very careful not to apply too much current because it is very easy to blow one. Actually, it's not just blow one, but you can easily burn the LED out. So for most LED, the recommended voltage would be 5 volts. And sometimes with this 5 volts, you still need a resistor. Then most LEDs have two different size connectors. The long connector is the anode and should be connected to a power source, to a positive, to 5 volts, the anode. And the short connector is a cathode and should be connected to a common ground. So this is an example of an LED. Of course, the longer LED should be connected to power source or to 5, for example, to 5 volts. And then, of course, this should be connected in the common or ground. Do not interchange it because you may destroy, or you may your LED will be non-functional. Okay, next is we have the capacitor. So capacitors come in many shapes, sizes, and capacities. So a capacitor stores and discharges electricity similar to a battery, except the capacitor charges and discharges rapidly, often in seconds or fraction of seconds. So the capacitor can be used to smooth the flow of electricity, filter the flow of electricity to allow so much through, or for a large quick burst of electricity like a camera flash. Okay, as it is said that capacitor can be used to smooth the flow of electricity. For example, if the needed electricity is a flow of electricity, for example, 5 volts, or for example, it's not enough. So the capacitor, since it has a stored charge, it will compensate for the lack of electricity. So for it to go, the operations go smoothly. And then, for example, if the electricity is too large because of the quick burst or power surge, so what will the capacitor do? The excess electricity will be stored in the capacitor. So that's why the usage of capacitor is used to smooth the flow of electricity. And then care should be taken when dealing with capacitors to make sure they are fully discharged before handling them to avoid getting an electrical shock. Actually, there is a electronics major. Actually, it's an instructor. If you're familiar with cathode ray tube TVs, the fat TVs, because as I've learned as a computer major, as long as the uh, the power outlet is not is the plug is not connected to the power outlet, then it will have no charge at all. They say it is different with the CRT televisions, because even though their plugs are not connected to the outlet, they still have charge because they have a very big capacitor, and it might harm, it's not might, it will harm you if you are not very careful with those CRT TVs. Okay, these are examples of capacitors. As the slide says, they come in various shapes and sizes. Okay, next is we have the integrated circuit. An integrated circuit, or IC for short, is a semiconductor wafer that contains thousands or millions of tiny transistors, resistors, and capacitors that are used to perform certain functions. There are millions of different types of IC, and one example is the ATmega 128 microcontroller used in the Arduino. So virtually all electronics have some ICs in them. So this is an example of an IC. And this is the ATmega 328, the IC that is connected, or that is included in your Arduino. Okay, next, after the electronic components, we're going to deal with electricity. So what is electricity? So electricity is created when particles become charged. Some particles become positively charged while others becomes negatively charged. Particles with opposite charges attract each other, while particles with the same charge repel each other. Opposite attract, same repel. As there's a saying like that. Even actually, I think for people, they said that opposites attract each other. And then since electrons are in constant motion, occasionally an electron will escape from its atom and joins another atom. And then the atom that the electron escaped from now will have a net positive charge, while the atom that gained the electron will have a net negative charge, because electrons are negatively charged, while of course the atom has a positive charge. Of course, when the electrons left that atom, because there are more numbers of positive for the atom, so it's a net positive charge, while the electron who transfers from another atom, then it will have a net negative charge. So electricity is this flow of electrons. So the electrical conductivity of a metal is measured by how easily an electron can escape from its atom. So these following elements, such as copper, silver, and gold, are some of the best conductive materials because they have only a single valence or outer shell, an electron that moves with little resistance. So that's why it is, these are categorized, copper, silver, and gold are categorized as the best conductive material. And if a copper wire is connected from one end of a battery to the other, the flow of electrons would go from the negatively charged end to the positively charged end. So we have this one. Example, you have this copper wire. From negative to positive. The negative electrons will be attracted to the positive. So that's why the flow of electricity will be this way. And then the reason that electricity flows in this manner is oppositely charged particles attract, as it is said. Therefore, the positively charged end attracts the electrons, causing them to flow from the negatively charged end. Okay, next is we have current. Current in an electronic circuit is the flow of the charged particles, or again, of the electrons. The current is measured by the number of charged particles passing the point of the circuit that is being measured per second. So current is measured in amperes and can be measured with most standard multimeters. So 1 ampere is equal to 6.241 times 10 raised to negative 10 raised to 18 electrons passing the point being measured per second. So for example, for an analogy, for example, this is a pipe and there is water. The analogy for electrons is water. So current is equal to charges passing this point per second. That's the meaning of current. Okay, next is we have the voltage. So voltage is the amount of potential energy between 2 points, where one point has more charged particles than the other. The difference in this charge is called the voltage. Think of the voltage as the pressure within the circuit to push the charged particles through the circuit. So voltage is measured in volts. So this is an example. For example, again, the pipe. And because there is a greater gravity in here, so than compared to this part, so where is the more pressure is located? There is more pressure in here because of gravity. So again, voltage is equal to the pressure pushing the water within the pipe. Okay, next is we have the resistance. So resistance is how much the flow of current is reduced or impeded. So all circuits have some resistance from the wire and components that make up the circuit. However, most circuits include resistors that add extra resistance to the circuit. So these resistors enable to limit the flow of charged particles within the circuit, specifically for LED, because LED has a tendency to draw more power, to draw more electricity, and this will cause the LED to burn out earlier than expected. So it is recommended for if you're going to use an LED, you have to have a resistor to prolong its life. And then resistance is measured in ohms. So this is an analogy of resistance. Okay, there is a resistance in this part because you reduce the flow of the charged particles or electrons compared to the left and right side. Okay, so since we've already discussed the current, the voltage, and the resistance, actually it's related to this law, which is Ohm's law. So Ohm's law stated that the current flowing through a circuit is directly proportional to the voltage applied to the circuit. This means that if the voltage of the circuit increases, then the current will also increase if the resistance stays the same. Then Ohm's law states that current flowing through a circuit is inversely proportional to the resistance of the circuit. This means that if the resistance of a circuit increases, then the current flow will decrease because it's inversely proportional. And then the only condition also is if the voltage stays the same. So we have this following formula. Okay, I is for current, and then V is for voltage, and then R is for resistance. I is equal to V over R. And then there are also variations for Ohm's law. Actually, do not be, it's not really strictly this is the formula for Ohm's law. There are also variations. For example, if you're looking for the current, so this is the formula. V over R, voltage over resistance. But what if resistance is missing? So if resistance is missing, it will be R is equal to V over I. And then if you want to find the value of the voltage, we have I times R, current times resistance. So you have to remember this one so that you can easily get the values for resistance, volts, and of course the current. Actually, it's the easier one is this one. We have the V over IR. It's easier to remember than I is equal to V over R. Actually, they are all correct. There is no the best. No, it depends upon with what you are looking for. Okay, next, what is power? So power is the amount of electrical energy transformed into another type of energy, heat, light, or work per second. So power is an important concept because it is what allows our electric circuit to do something. For example, if there is a circuit with a battery and a resistor, the resistor will convert the electrical energy to heat or thermal energy. All resistors also have a maximum power rating that they can handle. Therefore, to ensure that we do not damage the resistors in a circuit, it is needed to know how to calculate power. So, power is calculated by multiplying the voltage by the current and the unit, and it is measured in watts. So, it's very easy. Power is just multiplying the voltage by the current. So, its formula, power is equal to V, voltage times current. And the unit of measurement is watts. Okay, next, we have the resistor color codes. So, the value of a resistor is marked on its body using color bands. The majority of the resistors contain 4 bands, that's the most common, but there are also some resistors that have 5 or 6 bands. With a 4-band resistor, the first 2 bands, from left to right, indicate the resistor's value. The third band is the multiplier, and the fourth band is the tolerance. So resistors that have 5 bands use the first 3 bands to indicate the resistor's value. Then the fourth band is the multiplier, and the fifth band is the tolerance. So again, this is a picture of a resistor, common. These are all 4-band resistor. So these are the color codes. Actually, we're not going to deal with the resistor color codes and how to calculate its actual the actual value of the resistor, but because you have a separate subject. But I just want to know that this resistors has these color codes. So the tolerance level tolerance color is silver and gold, and there is also There's sometimes, depending upon the resistor, that sometimes there is no color. Okay, for the summary for this chapter, so there's a brief introduction to electricity, and we have already tackled the popular electronic components. These are mostly used in Arduino boards. Again, do you have any questions? And if you have any questions, just feel free to comment and ask. Thank you very much, and again, good day.